Welcome to question 2. Now, the letters A to F in the table below represent 6 organic compounds. For some reason, I'd like to focus on this box without looking at these questions. And I want us to quickly go check something here. All right, I hope this is clear enough. We're just going to write everything we can about each box. All right, now if you look at the first one, I've got CH3, CH2, CH2, and CH3. Okay, what can you tell me about that? There are 4 carbon atoms, all right, and 3 plus 2, 5, they are 10. So this is C4H10. Okay, what can you tell me about C4H10? Number 1, it's an alkane, and the name is butane, and it is a saturated compound. Let's move to B quickly. If you look at B, I have C. Let me draw the structure just in case. That's what we have. All right. How many carbon atoms do we have as well? We've got 4. Just going to drag this here. Okay, we've got 4. All right, now the question is, what functional group does this belong to? You have a C bonded with a oxygen there, double bond. You need to know quickly that that is sandwiched between 2 alkyl group. Guys, it's like if you live in the locations, you've got what you call a quarter. And a quarter is a bread with the burger, all right, the local burger, if you know what I mean, and with another bread, just similar to your own burger. So it's called a quarter, and a quarter is spelled as K-O, that, all right, and that is actually the beginning of the word ketone. So that's my ketone because my functional group is sandwiched. So this is a ketone. But how many carbon atoms? I've got 4. So this is butane. Now carbon 1, carbon 2, it's on carbon number 2, and it ends with on. So it's butane 2 on. All right, let's go to the third one. We're just quickly moving through before we start answering. You need to familiarize yourself with the whole structure before you start answering questions. Otherwise, you might miss something out. All right, C is CH3, CH2. If you are not sure here, please draw the structure. CH3, then I have a carbon, I'm here. Then I have another carbon, then I have another carbon with 2 hydrogen atoms, and I have another carbon with 3 hydrogen atoms. Now let's check. Remember, around every carbon there must be 4. So 1, 2, 3, 4. This is fine. That looks like a double bond. Now 1, 2. There's something missing here. If I do that, how many do I have around this? 3. I need 1 more, which makes it 4. 1, 2, 3, 4. This is sorted. Let's go check this. 1, 2, 3. Oh, now it's fine. So this is an unsaturated, and not just unsaturated, it is actually an alkyne. So that is alkyne. And what is the name? 1, 2, 3, 4, 5. 5 is pent. Okay, I'm just gonna borrow space here. Pent. Now this is carbon 1, carbon 2, carbon 3. Remember, it is always on the lowest carbon. So it is carbon 2, pent 2 ine. And what's the general formula? I'm borrowing space from E, CnH2n minus 2. All right, unsaturated, by the way. Okay, what about D? I'm going to clean this. D, okay, still leave that space. D is butyl propanoid. All right, that is an ester, and that is formed. If it's it's formed from butanol and propanoic acid. Okay, and the process is esterification. So we have butyl propanoid. Remember, we start from the alcohol section. Beautiful. Let's look at E. All right, E is an alcohol, and there's a primary one, 4 carbon atoms, so this is butanol. It's an alcohol and it's primary. Oh, I love this one. Let's look at this. This is a haloalkane. All right, and my longest chain, 1 2 3 4 5 6, 1 2 3 4 5 6 7. This is my longest chain. I'm going to put a box around that longest chain. Okay, whichever one is not in a box becomes a side chain. All right, side cheek. No, sorry, side chain. I'm going to say a side cheek there. Okay, that's just chemistry, having fun. Now, what is this here? That's a methyl group. Okay, so a methyl group is already a side chain. Now, let's look at the numbering. If I number from here, I have a bromine group here, another one, a bromine compound, which is closer to the end. So this should be my carbon 1. Because if this is my carbon 1, I'm going to have a problem. 1, 2, 3. The first side or branched is on carbon number 3. No, but on the side, it's on carbon number 2. So it's 1, 2, 3, 4, 5, 6, and 7. So what is the name of this compound? Okay, I'm going to split it first. I have a 2-bromo. I have a 3-bromo. This is not the name. And I have a 5-methyl. And because it is 7 is hept. So I have heptane. Now let's combine the name. I am going to start by writing heptane. I'm going to write backwards. Now I have a B and a M alphabetically. The B comes first. All right, and because I have bromo, I will then combine 2, 3 dash. It is dibromo because there are 2 bromine attachments there. And then I have dash 5 dash methyl. Please understand that between a letter and a number, you must put a hyphen. And between a number and a number, you must put a comma. So it is 2, 3 because I have 2 bromo and 3 bromo. They are bromo, I combine them, gives me 2, 3. But don't forget the word di, meaning 2. All right, and then I have 5-methyl. Please, it is important, arrange alphabetically. Let's go look at the questions now. This looks very interesting. Is compound C saturated or unsaturated? Give a reason for your answer. Question has been answered. Compound C is unsaturated. Why? It contains a triple what? Bond or a multiple bond. I'm done. Okay, let's answer. Because of the PDF. 2.1. C is unsaturated. And what is the reason? It contains multiple what? Bond. And that is easy because we drew the structure. 2.2. Write down the letters of each of the following. The one that represents an ester. Oh, we did. D. Can I just write my answers there? D represents an ester. The functional isomer of butanol. If I take, butanol is aldehyde. If I take you back quickly to my cake, check this. Aldehyde and ketones are functional isomers. So my aldehydes will end with al and my ketones will end with on. So an aldehyde has a functional isomer with the same number of carbon atoms as a ketone. Aldehyde and ketones. So al and on. Let's check. The question says, which one of the following a functional isomer of a butanol? If it's a butanol, a functional isomer has to be a ketone. Which one is my ketone? B. A compound with a general formula CnH2n minus 2. C. Alkyne. Do you see that I've answered all of this? A compound used as reactant in the preparation of D. Let's go check. What is D? D is an ester, and what do we need? We need butanol and propanoic acid. Oh, is there a butanol? Oh yeah, butanol. So my correct option is what? E. Write down the structural formula of the functional group of compound C. All right, so 2.3.1. C, what did we say about C? C is an alkyne. Oh, that is it there. But I want the you need to read the question very well. It says the structural formula of the functional group. Since it is an alkyne, that is my answer. That is the functional group. Please take note. The structural formula of the functional group. This is the alkyne. All right. 2.3.2. Structural formula of compound D. Easy. It's an ester. All right. It is an ester. Do you remember that an ester would have this? COO. All right. It depends on how you want to draw it. You want to draw the oxygen on the side, but one thing you must know is this. Okay. Let me put the oxygen on the side. One thing you must know is this. We have an alcohol and a carboxylic what? Acid. On the carboxylic acid, that's where you have the double bond. So the oxygen, let me do something here. The oxygen is the breaking point of the two. Okay? So look, let me use a different color because I'm going to take it out later. That's what separates the two. So your alcohol must be on one side and your carboxylic acid on one side. But which side will my carboxylic acid be on? The side that has the double bond on the carbon bonded to the oxygen. All right, because that is the original formula of a carboxylic. So you've got that. So which means my carboxylic acid will be on the side. And which carboxylic acid do we need? Prop, which is 3 carbon atoms. Where's my page? 3 carbon atoms. First carbon, second carbon, third carbon. And on the alcohol, we said but. We need 4. 1, 2, 3, and then 4. And all you need to do now is to complete your structure by drawing the hydrogens around them. 1, 2, 3, 4, 5. You just draw. Don't forget, it must not be more than 4 around the carbon. Each carbon atom must have 4. And that's my structure there. Butyl 4. All right, and you have propanoic acid. So don't forget where that's oxygen. The oxygen is like a ring that holds the two sides together. All right, a chain isomer of A. What is A? A is, what did we say A is again? Let's just go back. Our A is butane. A is butane. We want a chain isomer of butane. Let's quickly define what a chain isomer is. All right, I'm just going to take this out. Let me take this out quickly. All right, doesn't want to move. It's fine. Oh, okay. Chain isomer, or rather, let's quickly talk about isomers. Let's quickly have a crash course on isomers. Organic compounds. So we are just not answering questions, we're revising, all right, with the same molecular formula, but different structural formula. So that's the general definition. Structural formula. However, there are 3 types. Let's look at the 3 types. We have chain isomer, we have positional isomer, and we have functional isomers. Let's define quickly. What are chain isomers? Look at what I'm going to do here to save time. I am going to underline the prefix. Organic compound with the same molecular formula, but how are they different in structural formula? Different chain length. So if you are going to define, I hope you get what I'm saying. You write the first part that I underlined. Organic compound with the same molecular formula, but different chain length. The chain length is what we mean by different structural formula. All right. The next one, organic compound with the same molecular formula, but different position of side chain or functional group. So you see the keyword, position. What about functional? Organic compound with the same molecular but different what? Functional groups. Already we spoke about this as cake. So this question wants us to draw a chain isomer of butane. All right, so I have butane. This is what the examiner drew. The examiner drew that. Examiner had that. Now CH2. All right, so we want to draw a chain isomer of butane. Guys, make sure the chain lengths are different. That's all. The chain length here is 4. Connected 4. Make yours 3. All right, you cannot have 2 anymore. But now there is 1 carbon short, and you want to have C4H10. So 1, 2, 3, I'm going to put another carbon there to make it 4. All right, so you would notice here, my chain length now is 3. So let's have my hydrogens. Good. We want to draw the structure, but let's name. We're learning, so let's name. 1, 2, 3. Propane. Okay, longest chain. Carbon 1, carbon 2. Oh, there's a side chick here, a side chain. Sorry. And this side chain is a methyl on carbon 2. 2-methyl propane. All right, I hope we are good with that question. Beautiful. So we've answered all of that. Now let's look at 2.4. Just going to go to a different page now to get my 2.4 sorted. Rearrange this so that when you get the PDF, it's all in order. 2.4. Write down the IUPAC name of compound F. I think we did already. We did answer that question. This is why, look, you were not wasting time. If you did what I did, you would not be wasting time at all. 2-bromo, 2,3-dibromo, 5-methyl heptane. All right, 2,3-dibromo dash 5-methyl heptane. Done. 2.4.2. The balanced equation using molecular formula for the complete combustion of A. Listen, when alkanes burn in oxygen, that's combustion, they form carbon dioxide and water. So we need to write that and balance. A is C4H10. I like to do something very crazy here. This is crazy physics. It's a principle. Let me go to a new page. I have C4H10. Remember, no matter the alkane, it will give you carbon dioxide and water. This is what I do. It's very crazy. But it only works for this reaction. A lot of learners say, sir, does it work for all? Nah, just this reaction. I start by putting a 2 there. Takes you seconds. 2 times 4 would give me 8. This is my answer sheet. So I'm done with this 4. I move to this 10. I copy and paste. It's crazy. All right, I'll go back again. Put a 2. 2 times 4, 8. Move to 10. Copy and paste. Now work on the side. 8 times 2 would give me 16. Plus 10 would give me what? 26. Now divide that 26 by these 2. That will give you 13. And it is balanced. It is balanced. Let's try something else. And you can try as many as you want on your own. C5H12 plus O2. Remember, it will give you carbon dioxide and water. Let's balance. What's the first rule? Put a 2. 2 times 5, 10. There's a 12 there. Copy and paste it. 10 times 2, 20. Plus that 12, 32. Divided by 2 would give you 16. Now there's a problem here. All of these are even numbers. You've got to divide it by 2 because you need to use the lowest. So I'm going to have this divided by 2 would give me that. 8O2. I'm going to have 5 CO2 and 6 H2O. And it is automatically balanced. So remember, when alkanes burn in oxygen, they form carbon dioxide and water. All right, that is, oh, my 17 marks. Swift, I have my 17 in the bag. I am moving close to my distinction. Awesome. Let's go and deal with question number 3. In question number 3, we're dealing with intermolecular forces. We're dealing with physical properties of organic compound. I'm going to give you a crash course before we answer the question. Physical properties of organic compounds. All right, let's get a new page. Okay, we have a new page and let's look at physical properties. And under physical properties, we're looking at 2 things quickly. All right, number 1 is the boiling point. I'm sure you should remember your definition. Boiling point is a temperature at which the vapor pressure of a liquid, because that was changing, now would equal the what? Atmospheric pressure equals the atmospheric pressure. We have a boiling point. Number 2, we need to be able to define vapor pressure. And how are we going to define vapor pressure? It talks about the pressure. So it is the pressure exerted by the vapor. On a liquid. All right, you must be able to define this. All right, at equilibrium. We must mention that in a closed container. Please be able to define both. And what are the factors that affect both boiling point and vapor pressure? There are a few factors that affect them. Number 1, intermolecular forces. Number 2, chain length. Number 3, molar mass. All right, so these are a few factors that affect our boiling point and vapor pressure. Let's quickly look at intermolecular forces. IMF. Just going to write IMF. There are 3 of them. And we know what we have. We have what? London. We have dipole. And we have what? Hydrogen bond. I like to look at it this way. Okay. Just going to write here. This is the weakest. Let's draw that. This is the weakest. So this is just a crash course. And this is the strongest. So obviously, dipole is just in between. Where do we find London? We find London between carbon and hydrogen. So if you look at carbon and hydrogen, you actually find it in all organic compounds. All right, so we have all organic compounds. So all organic compounds will then have that. What about dipole-dipole? We're going to find dipole-dipole between carbon and a halogen. All right, that's very, very important. Between carbon and a halogen, carbon and an oxygen, and it could be that or the double bond. This for alcohol and that for your aldehydes and ketones. So where are we going to have this? We have alloalkanes, which is your C to X there, where X is a halogen. We have aldehyde, double bond there with oxygen. We have ketone. We have esters. We have carboxylic acids. And we have alcohols. So you have dipole-dipole in all of this. And the strongest one is between oxygen and hydrogen. And that you would have alcohol, which is basically one side of hydrogen bond, very key, and carboxylic acid, which is two sides of hydrogen bond. All right, so this is a crash course quickly on your intermolecular forces. I'm going to add something to the factors that affect our boiling point and vapor pressure. Number one, we looked at intermolecular force. Let me just write it here. Position of side chain also affects. All right, number two, let's look at chain length. Chain length. Chain length could actually also go with molecular mass, because the longer the chain length, then the bigger the molecular mass of the organic compound. All right, the longer the chain length, the stronger the net intermolecular force. The stronger the net intermolecular force. I'll explain what that means. The stronger the net intermolecular force, all right, because there are more points of contact. Because there are more points of contact of forces. More points of contact of the intermolecular forces. All right. And under this, I could also refer to the shape. Let's quickly talk about the shape as well. All right. Straight chain hydrocarbons, straight chain, let me just say organic compounds, will have a higher boiling point. I'm just going to write BP. Then their spherical isomers. We used, I'll give you an example here. We did a question in question, okay, some of you are still writing. We did a question in question 2 where we talked about butane. So if I have my butane, all right, that's a straight chain, and its isomer is 2-methyl propane. Now, the shape here is spherical, and this one here is a straight chain. Now, the straight chain hydrocarbon would definitely have a higher boiling point, because the intermolecular forces here are stronger than this one. The more spherical we get, the weaker the intermolecular force between the organic compounds. So take note, the more spherical we get, the weaker the bond then becomes. All right, it's a crash course. I'm sure you know all of this. This is just reminding us. And the molar mass, guys, is basically similar to the chain length. The bigger the molar mass, when you talk about molar mass, automatically now we're increasing in size. The last one, which is the position. of the side chain. All right. If the side chain is on the terminal carbon, I'll give you a very good example. The intermolecular forces are stronger. For example, if you look at butane 1-ol and butane 2-ol. All right, let's just quickly draw that. I have that, and I have this. Now, this is butane 1-ol. We are exposing this bond. This bond is exposed, which makes this stronger. This is exposed, so this one would have a stronger net intermolecular force, and therefore have a higher boiling point. And my final slide before I answer questions, I hope this is making sense, guys. These are factors that could affect your boiling point. My final slide would be, how do I answer my questions? We use the ICE method to answer our questions. I would be to identify the type of intermolecular force. You would see how I'm going to use it. I don't want to write too many stories when I answer a question. Identify the type of intermolecular force, and I've taught you how to identify. This is how you identify. All right. Identify the type of intermolecular force. Number 2, C, you compare the strength. You know the strength already. Compare the strength of the intermolecular force. And number 3, you talk about the energy required to overcome the intermolecular force. All right. If it's a strong intermolecular force, then we talk about a lot of energy required to overcome that intermolecular force. I'm sure I'm going to use these 3 to answer a question. And finally, substances with high boiling points. Substances with high boiling point have a low vapor pressure. So we are going to connect these 3 to this conclusion. So number 1, you identify the type of intermolecular force. Number 2, you compare the strength of the intermolecular force. Number 3, you talk about the energy required to overcome the intermolecular force. And then you must know that substance with a high boiling point will have a low vapor pressure. Let's look at questions. All right, so we're looking at question 3. Just need to go find my question 3 quickly. All right, there is my question 3. Question number 3. Let's clone that page quickly and drag that page down just after the notes. Awesome. I have my question 3. Oh no, I think I still need to drag down just one more. Yes, just one more. Beautiful. Okay. Now, 3 compounds are used to investigate one of the factors that influences boiling point. The results obtained are shown in the table below. Let's see what we're talking about. We have butane, the first one, just in case it's not clear. You have butane. You have an, okay, so let me say an alkane here. So this is an alkane. That's an alcohol. And that is a carboxylic acid, Cab-As. All right. Now, in one investigation, okay, let's check something here. The molar masses are fairly equal, 58, 60, and 60. Now, that already tells you that we are trying to control that. So, this is my control variable. In case we are asked, that is kept constant. Okay. Now, what are we changing? We are actually changing the functional group, because I move from alkane to alcohol to carboxylic acid. So I am changing my functional what? Group. That's going to be my independent variable. What I am changing becomes my independent variable. And boiling point, because that's the result, boiling point becomes my dependent. So the functional group of a compound determines its boiling point. All right, and when I talk about functional group, I am actually talking about, again, the type of intermolecular what? Force. If you remember that table I had all the homologous series divided according to the type of intermolecular force. So they are connected. The type of functional group, all right, determines the type of intermolecular force, which determines my boiling point, even if I keep the molecular mass constant. Oof, I have answered a lot of things. My independent variable, my dependent is boiling point, control is what you keep constant to make an experiment fair. All right, that's why we have control, to make an experiment fair. All right, let's answer the questions. In an investigation, the boiling point of compound B and C are compared. Is this a fair investigation? Write down yes or no. Refer to the data in the table. Look, is this a fair investigation? Yes. Why? There is a control variable of molecular mass. So what's going to be my answer? 3.1.1. Is this fair? Yes. Every time you have a control variable, then we talk about a fair experiment. I'm going to say compounds have the same molecular mass. Compounds have the same molecular mass. All right? Compounds have the same molecular mass. Another reason you could write is there is only one independent variable. There is only one independent variable. So it makes it fair. So we are only comparing one difference between them. Write down the independent variable. Guys, I think that has already been answered. What's my independent variable? Functional group or type of intermolecular force. Whatever it is that you're changing becomes your independent what? Variable. Independent. Let's write it. Independent. Okay. Independent. I hope that makes sense to us. Independent variable. So functional group or type of intermolecular force. That is 3.1.2. I'm just going to put an arrow there to let us know that that's the answer. Lovely. Which one of the compounds A, B, C, or D has the highest vapor pressure? We talked about that. That a substance with the lowest boiling point will have the highest vapor pressure. So which one is the one with the lowest boiling point? It is A. So my answer is A. 3.2. A, which we know as what? Butane. And what is the reason? It has the lowest boiling what? Point. Please do not say they are inversely proportional. They are not. Please. They are not inversely proportional, because when you talk about inversely proportional, then you talk about a proportionality constant, and there's no constant here. All right. So they are not inversely proportional, but we know a compound with a high vapor pressure will have a low boiling point, and we're done. Refer to the intermolecular forces present in each compound and fully explain the trend. Now, this is where I go with the eyes. I have butane, propanol, and ethanoic acid. Let's get a fresh page. A is butane. B is ethanol. Is it ethanol? No, propanol rather. Propanol. propan-1-ol, which is an alcohol, propan-1-ol, and C is ethanoic acid. All right, that's why I saw the ethanoic acid. Okay, guys, how do you answer? I identify. A has London. In fact, we can then start saying weak London forces. B has one site of hydrogen bond. Don't write too many stories. C has two sites of hydrogen bond. Now, what have you done? You have identified. C, what are we doing? We're comparing the two sides of hydrogen bond in C is stronger. And when you say stronger, we need to use the word than the one side of hydrogen bond. Very simplified principle in B, and also stronger than the London forces. We're not writing stories, we're very direct in A. So I see. Now we talk about E, the energy required. Good. E. The energy required to overcome the hydrogen bond in C is higher than in B and A. Therefore, the boiling point of C, you see, they said fully, boiling point of C is higher than that of B, and B higher than A. Guys, you have your full marks, and I hope it makes sense. I, C, E, and then you conclude. I, C, E, and then you do what? You conclude. I hope it makes sense. All right, I hope that makes sense. I, identify. C, compare. Make sure you keep mentioning C, B, and A in that order. All right, energy, C, B, A in that order. Therefore, the boiling point also in that order. And you're done. All right, which compound, butan-1-ol or propan-1-ol, has the higher boiling point? Give a reason for your answer. All right, so we're looking at butan-1-ol and propan-1-ol. Now, if you look at both of them, let's check something. Butan-1-ol and propan-1-ol. What do you see? This one here has 4 carbon atoms, and this has 3. So we're basically talking about the chain length. And the longer the chain length, remember what we said? The longer the chain length, the higher the boiling point. So what's my answer? My answer would be butan-1-ol. And what would be your reason? My reason would be a longer chain length. I could use that. I could also use a bigger molecular mass because there's an extra. All right. And we are okay. Oh, I could also use a larger surface area because of the chain length. So the surface area is larger. All right. Bigger molecular mass or bigger molecular size, whichever one the case may be. All right, guys, this is how to answer your boiling point and melting point. Question answered swiftly. You need to know how to get your marks quickly and move to the next question. Organic chemistry is max in the bag for you. All right, let's go to our next question where we deal with organic reactions. And again, I am quickly going to summarize organic reactions for you. Let's get a fresh page and summarize organic reactions. Good. Organic reactions. I'm just enjoying myself this Saturday morning.